Hello and welcome to this episode of Microchips, and on the bench today we have another piece of test equipment from our friends over at ZOYI, ZT Tools. They have kindly sent this over for me to look at and test and review, so that's what we'll do. We'll put it through its paces and see what it can do, and it definitely looks like a very interesting piece of test equipment. So yeah, quite excited to give this a test. But before we start, don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me a coffee, have a look at my website, microchips.net. Let's get started. So this is a LCR meter. So what is an LCR meter? Well, it does inductance, capacitance, resistance, and it also does battery resistance as well. So we're just having a look at what's in the packet here, and we've got 3 sets of test leads, which yeah, it's a surprise. And we've got a USB-C charger, we have the test meter, we have an instruction manual, and we have this bridge that we have to put in should we use the 4-wire testing leads. So let's have a look at the test leads. So these are just your normal probe leads, and they've got a very, very nice sharp end on them, which I do like. Leads aren't completely silicone-y, a bit plasticky, you know, but yeah, they'll do, no problem. And for the second leads, I believe these are for the battery testing, and it has this connector on top that goes onto the top of the meter, and this is where we can test our battery and test our internal resistance of our batteries. Now, why internal resistance of batteries? Well, so believe that the internal resistance changes as the battery ages, so maybe it's a good way to see if the battery is aging. So our last set of leads are our 4 wire leads for the component testing, which are very nice. Got nice plated tips on them, nice springy clips. So yeah, got definitely plenty of test leads there. So let's have a look at the meter itself. Typical ZOYI design with its red and dark grey blackish stripes. I would have liked a replaceable battery like on the oscilloscope, instead of it being a internal not easy replaceable battery, should we say. But looking at the display, nice and sharp, nice and bright, plenty of information on the display, nice and easy to read. We've got all our functions that we can scroll through, or we can leave it on manual and let the meter decide for us. Now, there are many settings on this that we're not going to go through. We're just going to go through the most useful settings that I found. But that level setting is gives you more sensitivity, and you got the speed that which is the testing speed. But for normal use, we should leave that level at 0.1. I believe if you want to measure something in circuit, then we need to change that figure. But this is what we're going to be testing. We've got some inductors, we've got some capacitors, we've got some electrolytic capacitors. And let's have a look. So just have a quick look through the instruction manual, and as you would expect, it's nice and colourful, nicely laid out, with all the relevant information that you require to operate your meter. So you can see there we've got resistance, capacitance, inductance, internal resistance up to 100 henries and 100,000 microfarads. And we've also got the frequency table, which is for you to set the frequency of the test, and we've got all the necessary symbols for the information that the meter gives you. So what is important are these frequencies and the capacitor, resistance and inductor, because the different frequencies test the component and will give you different readings. So once you've found the sweet spot for the test frequency, we can just literally just plug our component in. So what we have here is a 1000 microfarad capacitor plugged into the front. You can see it's reading 960 microfarads, which is absolutely fine. But it is saying about a recommended frequency for the test, and as you can see, changing the frequency changes the reading. So we'll set that to the recommended frequency, and we've got 960 microfarads, which is close enough. No problem at all. So let's have a look at the other options for the readings. So I'll just scroll back to capacitance again. So we've got various different readings that we can have with the capacitor. We've just had wear and tear, we've got Q for quality, got X for reactive, got theta, which is phase angle. I'm not sure how you would read that, to be honest. And then you've got the ESR resistance, and it's showing you at the top that is ECAP for electrolytic capacitor. So definitely lots of things being tested there. So that was a Rubicon 1000 microfarad capacitor, and I think these were low ESR capacitors, which this definitely showed. Which you can definitely see there, it's absolutely low. So what we'll do is we'll plug in this Sanyo 1000 microfarad, and as you can see, the ESR is a little bit higher on that one than the Rubicon. Now ESR being equivalent series resistance, I believe. It's another way of testing the capacitor apart from the actual microfarad reading. There are some tables online that do show you what is a good and what is a bad ESR. Now this one is just a 2.2 microfarad, and this one has got 18 ohms of ESR, but it should be okay because it's a brand new capacitor, so I won't have to get used to working out what's a good ESR and what is a bad ESR. But there's definitely lots of readings to play with on this. So let's try some polycaps. Yep, fine, no problem. As you can see, it reads it very, very, very quickly when plugged into the front, which is excellent for quick checking new components should you want to find a matched pair or ones that are very similar in electrical characteristics for your design. Obviously you won't be able to take them off a circuit board and plug them into these front connectors because the lead would probably be very short, so you'd have to use the clip leads for those. But again, we've got different frequency readings or different frequency test parameters for testing certain values, and yeah, they're all testing absolutely perfectly. Let's try this capacitor. It should be a 10 nan. Yeah, absolutely perfect. I must say that this meter does read these components very, very, very quickly. 470 nanofarad. Yeah, it's fine. Well within tolerance. So yeah, it reads those new components very quickly. Very nice. Well, let's try this 100 picofarad, I think it is. And yeah, these capacitors were never that accurate in the first place. And this 100 picofarads is nearly 200 picofarads. Even with changing of the test frequency, it doesn't change the fact that this supposed 100 picofarad is well out. So let's try another one from the same packet, and this one's 150 picofarad, so you can see that these are yeah, really haven't got really not got a tight tolerance. Let's try some inductors. 3.3 millihenry. Yeah, fine, no problem. Now, some of the frequency of tests makes it look like, well, makes the meter think that it's a resistor, but put it onto the correct frequency, and yeah, you can see that it reads that inductor, no trouble at all. But we'll test some more inductors when we use the clip leads. So we'll just try a resistor, drop the resistor in, picks it up straight away, 680 ohm. Yeah, brilliant. It read that component really, really, really quickly. Very impressive. And again, there's different frequency recommendations for the component in test. So yeah, very nice indeed. Now let's try the clip leads. So to use the 4-pole clip leads, we need to fit this bridge in, and then we need to plug in the leads to the front. As you can see, these leads have 4 connectors. And let's try 1000 mic. Okay, let's change the frequency. Yeah, fine, no problem at all. Nice and quick on the reading. Let's try this Sanyo electrolytic. Yep, it wasn't as good as the Rubicon. Try the resistor. When the lead stays on, yep, try the resistor. Bang, 680 ohm. Recognised it was a resistor and give us the reading nice and quickly. You notice I'm performing all these tests under the automatic component recognition as well. So again, now because of the frequency, it thinks it's a resistor, but we change the frequency to a better test frequency. And there we have it, 470, 455 red, not too bad at all. Okay, let's try these 100 microhenries, absolutely fine. Reads them nice and quickly. So 22 microhenry, yeah, it's fine, it's well within tolerance. Not sure whether these are 5 or 10%. I think they might be 10%. It was a 2.2. Yeah, absolutely fine. Let's try some capacitors on the clip leads. So again, it picks up that it's a capacitor straight away and gives us the correct reading. So yeah, the auto component recognition is absolutely fine. So we're just going through there the level and the speed, just having a look at that. So now we're just using the standard probe leads that you would use for testing components in circuit. Obviously not putting my fingers across them because that will skew the readings a little bit. So let's measure some components in circuit. Now, we all know that measuring components in circuit can be non-conclusive due to influences of the components around the component under test. But these components that we're testing here don't have any influence on them, and they should be 8.2K and they're reading 8K, absolutely fine. So let's try some of these 0603s down here. These should be 10K, yep, fine. So it's reading these 10Ks in circuit quite nicely. Let's try this capacitor. Now, I believe this was 100 mic, but because it's got a resistor across it as well, it is slightly altering the reading, as you can see by this resistor that is actually across this capacitor. So obviously in that situation you would lift the component out and test it manually. Again, some more 0603 10Ks, and these long needle probes do get in and test the component just nicely. I really do like these probes, they're very nice, they're also very sharp. Let's try an inductor. So I've got some 45 microhenries that are used for FM discriminator demodulator circuits. And let's see what the meter makes of these coils. So we'll connect it up. And obviously we need to change the frequency. And once we've selected the correct frequency for the component under test, 45 microhenries. Now we should be able to adjust this as well. And sure enough, it does adjust. And does show us on the meter the adjusted reading. Very nice. So just out of interest, I had some coils made up, slightly different characteristic, but they should read the same, which they do, 45 microhenries. Will it adjust the same as the other one? Absolutely fine. Very nice indeed. So yeah, seems to be accurate enough. Very nice indeed. Now let's try the battery. So we need to connect in the battery test terminals to the top. Now will it automatically detect that we've got a battery under test? Maybe not with the leads connected in at the top. All we need to do is select the battery test, which is this one. Now it's showing we've got 3.2 volts, but the internal resistance is going a little bit wild in the red. So what we'll do is we'll just try and hold it a little bit better. And there we go. And I think the display turns white when it believes that the battery is normal, should we say. Now these are lithium ion batteries, 18650s. And they are a few years old, so I would expect this reading to be showing that it's aging, should we say. Let's find what it says in the instruction book. So we've got a reference guide here of internal references, internal resistances of batteries. So this is a 3000 amp hour. We should be getting 0.11, but we're definitely reading a bit higher than that. Well, I suppose that's to be expected because this battery is a few year old. But the meter still thinks it's good, so, and the battery still actually works, even though it's a few year old, so there's no problem. And on the other page there, we've got 18650, 20 to 90 megohm. And we should be checking against the manufacturer's data sheet for the battery and its recommended internal resistance, which is on the higher part of its recommended resistance, should we say. So that would indicate an older battery, which it is. So I'm just changing the test speed to fast, and as you can see, the fast is nowhere near as accurate as the slow reading. But all in all, a very nice meter, very capable, got plenty of functions. There's a USB-C charging point under there, and also that's a way of updating the firmware. Yeah, typical ZOYI design, red and black, very nice. So yeah, definitely a feature-packed meter with plenty of readings for you to go off, and definitely plenty of ways to test the component that you are testing, basically. And yeah, I think it's a good inclusion to anybody's workshop. Do I like it? Yeah, I think it's great. I think it's an absolutely brilliant meter. So thank you ZOYI, Zotek Tools, for sending this in for me to have a look at. It's very appreciated. And stay tuned for the next meter that we're going to review, which will have a thermal imaging camera on it. Link will be in the description below to the AliExpress official seller for these. And that's it for this video. Thanks for watching. Don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me coffee, have a look at my website. Thanks for watching, and we'll see you in the next episode.